I'm going to start off talking a little bit about regulations and trends. As we have these four drivers driving the adoption of ultra-low GWP refrigerants from 2025. First, we have indeed the F-gas revision, which is for sure one of the most pressing issues of our industry today, accelerating the phase down of HFCs and enforcing further restrictions. We also have eco-design review, and for sure we know that the next revision will come with further and more stringent thresholds regarding minimum efficiency performance requirements. We also have PFAS. What is PFAS? Well, they are chemical byproducts created by HFOs when they break down in the atmosphere. And some are known to be highly persistent in the atmosphere and contaminating water, soil, and posing health concerns. So that's why the EU is considering to possibly ban PFAS under the REACH regulation. So it's unclear yet whether all HFOs or HFCs, or if any, might be included, but we will know by 2025. And lastly, we have the climate urgency, and I think everybody is aware that we are at a tipping point. And if we look at the latest IPCC report, we need to peak greenhouse gases emissions by 2025 if we want to stay on this 1.5 degree global warming scenario. So considering all of this, we see R-744 getting traction. Why? Well, but first, because if you use it, you don't have to worry about all these regulations that we just discussed going forward. Second, for sure, the commercial refrigeration deciders are looking for sustainable solutions to cool their goods, and CO2 has appealing physical characteristics, such as non-toxicity, non-flammability, no glide. It also has, of course, a GWP of 1, and regardless of the time period used, right? This table shows that while the GWP values of refrigerants over 100 years are used for decades for the evaluation of short-term effects, then a time horizon of 2 decades is becoming prevalent and highlighting that synthetic refrigerants are, let's say, less climate friendly. So that's indeed the appealing physical characteristics. And when we account for the economical picture, of course, CO2 refrigerant itself comes at a fraction of the cost of synthetic refrigerants. So we are not saying that CO2 is the only solution, but for sure, there are other naturals and also A2Ls, and L2Ls are needed, right? Because they act as a kind of shock absorber for these steep F-gas phase down. They can help us to get out of chemical refrigerants. But at Danfoss, we believe that naturals are the way forward, the future of refrigeration. And therefore, we work hard towards developing sustainable solutions. So Danfoss has pioneered the CO2 technology for both transcritical and subcritical systems for more than 10 years now, and has gained a valuable experience on thousands of installations, proving that CO2 can be applied in supermarkets, enabling both environmentally friendly and energy savings in all types of stores. And Danfoss has developed a broad ecosystem of components, starting for boosters applications, like multi-ejectors, like case controllers, like valves, line sensors, and so on and so forth. However, due to its properties, such as the high pressure and low critical point, it was still difficult until recently to integrate seamlessly CO2 in smaller condensing units formats due to their architecture complexity and cost ratio versus conventional systems. And since Danfoss has always prioritized the system efficiency, the simplicity and the reliability, for us, it was out of the question to launch a unit which would not run in all European ambient temperatures, for instance, or would not work with any kind of expansion device. That is why we are excited to introduce our first CO2 condensing units, which are simplifying the adoption of CO2 via seamless integration of system components, control strategies, which greatly reduce the complexity and the commissioning and also the system management. So what are the key benefits of these CO2 condensing units? Well, we know that in convenience stores, they need to deal with challenging installation constraints, right? Like space constraints, noise regulations. So we have put a strong focus on the ease of handling and the flexibility of the installation during the development of our high CO2 range. And for the technology to be used in every scenario, we have developed units which are very lightweight, extremely compact, and optimized for silent operation. First, indeed, we have plug and play and ready monitoring and management. The electronic controller comes with the unit inbuilt, pre-programmed, and so parameters are ready for use with the provided unit. You just need to connect the condensing unit to the case controller and optionally to a Danfoss system manager to get all the working operating data transferred and managed. Second, we are able to exhibit a very high energy efficiency thanks to the inverter-driven compressors with best-in-class seasonal efficiency. Third, those units are able to operate continuously, even under the hottest ambient temperatures across Europe, up to 46 degrees, thanks to the intelligent flash gas management and the high-quality components. And lastly, they are super quiet. Honestly, you can hardly hear them running. So that's a strong asset to these compressors and condensing units. So let's deep dive a little bit on the technical features of the first model. So this unit, single phase, delivers up to 4.6 kilowatts capacity at -10 degrees. It's a medium temp condensing unit. It is stackable and unique on such a similar capacity unit. It works also with pulsating valves, such as Danfoss AKVs, on top of the stepper valves, such as UKJ, and also thermostatic TE2 launched during Chillventa. It comes also with hinged service doors for easy access and commissioning. The weight is only 116 kilos. And as you can see, based on the dimensions, it's very compact. What about energy consumptions and overall CO2 emissions? So first, on the right-hand side, as you can see, these units have gone through a complete field trial campaign. And for instance, these units being installed in the south of France were exposed to over 40 degrees during this summer without any issue, and continuous operation was maintained. But if we take a look at the energy consumption, indeed, the consumption versus a conventional hermetic R-444 reciprocating unit is over 11%. And besides the GWP advantage of CO2, if we account for the full picture of all the greenhouse gases emissions, then we can use a different metric, which is named TEWI, or Total Equivalent Warming Impact, and which is the measure of the global warming of the systems based on the direct and indirect emissions. Means energy consumption plus gradual leaks plus potentially a catastrophic leakage, which can occur right across 10 years of operation, and also the end-of-life recovery. And the left-hand chart shows that the overall reduction of emissions is above 50% using CO2 against 404A. Let's take now a look at the larger model, which uses a two-stage compressor and hence delivers up to 20 kilowatts capacity at -10 degrees. And since it can operate also up to -45 degree evaporating temperature, it's able to deliver 10 kilowatts at a rating condition -35 degree. And as can be seen on the right-hand chart, the seasonal efficiency according to eco-design is clearly best in class with a CPR of 4. This unit also comes with a very small footprint and a large receiver volume, which enables the unit to deliver the capacity up to 100 meters pipe length and up to 8 display cases. So the same overall emissions analysis was done on this unit versus a conventional scroll tandem condensing unit using a modulating and a fixed speed scroll. And as you can see on the left-hand side, the energy consumption reduction is above 20% in medium temp, and the overall emissions, TWE, is over 60%. So in conclusion, the first ICO2 condensing unit delivering 5 kilowatts is already available today on stock and has proven its reliability in the lab, in the field trials up to 46 degree ambient temperature. It is clearly super silent, compact. It's also stackable to take up less space. It works with the Danfoss stepper valves and also the pulsating valves and also the thermostatic expansion valves T2. It offers also scalable connectivity, easily adapt to any cold room or display case application. And similarly, the larger 20 kilowatt model, which will be available by the end of the year, will be also followed by other models later next year. So stay tuned, come to our booth to see this unit, and I'm available for further discussion and question. Thank you very much.